Hello, everyone, and welcome to today's Learn Live session where we'll be covering enhancing your IoT solution security using Azure Defender for IoT. My name is Josh Demenge. I'm a cloud developer advocate for the data team at Microsoft, and joining me today is Joeline Kirui. Joeline, kindly introduce yourself.
Thanks, Josh. My name is Jolene Kiruri. I'm a senior cloud security advocate at Microsoft. I've mainly dealt with offensive security, but in Microsoft, I deal a lot around DevSecOps, IoT security, AI security, just anything security. And so for this session, please join us on chat at aka.ms/learnlivetv, so at least you can interact a little bit more. So Josh, did you know the S in IoT is for security?
There's no S on the word IoT.
Exactly my point. That's why we're having this session, just to demystify how you can actually secure your IoT security solution end to end. And we also have our moderator. Say hi to Bethany. Bethany is a cloud advocate at Microsoft as well, and she does a lot around artificial intelligence, machine learning. She's so just Bethany, maybe you can just greet us on chat and let us know how you're doing.
Thank you, Joeline, and thanks, Bethany, for joining us today as our moderator. I'm excited today to cover with you two Learn modules on IoT and security. The first Learn module is examining security fundamentals for IoT. The second is examining Azure Security Center and Azure Defender for IoT. You can follow along by scanning the QR codes for these two Learn modules. So, Jolene, what are the learning objectives for the first Learn module today?
As you've heard, the first module is examining security fundamentals for IoT. So during this session, we're going to first of all describe security recommendations. Like many other compliance bodies like CIS, which gives you recommendations for like hardening your OS, your database, your web servers. We have also several security recommendations for IoT solutions, which we'll cover in this module. And the second learning objective that we have is describing the IoT security infrastructure and security in-depth strategy. So like any other deployment, you need to have a security strategy in place to make sure that everything is secure end to end. I always give this analogy that you have to be sort of secure almost throughout, and a hacker has to be lucky only once for them to compromise the system. So you have to be quite intentional about having a strategy in place to secure your IoT security infrastructure. And the third is describing threat modeling and mitigation techniques. So in this session, we'll also cover like what exactly is threat modeling? How can I do threat modeling on my IoT solution? And what can I do to mitigate the threats that are targeting my IoT infrastructure?
Thank you. For the second Learn module, we'll describe the Azure Security Center concept. So this is where we start having an introduction to Azure Security Center. We'll also have our first introduction and mention of Azure Defender for IoT and see the IoT options and features for the agent-based implementation. And the last thing, we'll describe IoT security alerts and custom alert implementations. And hopefully all along, we'll try and ensure to show you demos on Azure and how everything comes together. So without further ado, Jolene, take us through security fundamentals for IoT.
Okay, thank you, Josh. So in this, as we earlier mentioned during the learning objective, we want to see how you can be able to review security recommendations, examine the IoT security infrastructure and security in-depth strategy, and as well as examining the threat modeling and mitigation techniques. So we have a report out from Microsoft under aka.ms/IoT signals report. And in this, they say that the IoT security is still a very major priority in all IoT infrastructure or IoT solutions. So in fact, 91% of survey participants expressed concerns about IoT security. So data privacy tops the list of security worries at 46%. So followed by network level security at 40%. Other concerns include device security endpoints, managing and tracking each device, and ensuring software and firmware updates are made. So interestingly, organizations are not using a common best practice approach to security, with only 43% designing measures that assume breaches at every level of the IoT project. So this is quite key. In everything, you have to assume breach in order to make sure that your whole infrastructure, your whole solution is secure. So go on over to aka.ms/IoT signals report to check more about IoT security and IoT as of end of last year. So we're going to cover several aspects of security recommendations, and Microsoft has several security recommendations for individuals and companies working on IoT solutions. So in general, the first key aspect is to stay up to date. So by staying up to date, you're making sure that you are updating your firmware, you're updating your operating system, you're updating your application, the application that your IoT device is actually sitting on. So we have 0 days that are actually quite prevalent, like especially for IoT devices as well. And that's why we have to make sure that you are updating your devices as often as possible. If you're using a device that's vendor-based, you have to make sure that you're keeping tabs with the patches that's actually being pushed on a regular basis. We also have the second recommendation and general recommendation is to keep authentication keys safe. You're only as safe as your authentication, because if I have access to your identity, I have access to your keys, then it means I can compromise anything. I have control over the whole device. And another one is to use device SDKs when possible. So device SDKs implement security features such as encryption, authentication, and very many other things. We're going to cover that as well during the demo. Going on next. So apart from the general recommendations, we also have identity and access management. Under identity and access management, the first one is defining access control for the hub. So we have allowed permissions such as registry read, write, service connect, device connect. Josh, maybe you can show us how to define access control for the hub, for the IoT hub.
Right, let me bring in this screen right here. And right here we have our IoT hub that we've already created before this session. And like Jolene has mentioned, that one of the ways is to ensure that we secure access to the IoT hub. And one of the most common ways of accessing an IoT hub is through the use of shared access policies. So one of the way your device, or rather your device, will communicate to IoT hub is through a shared access, through a connection string that has a shared access, that has a SAS token or a key defined by a particular shared access policy. And if I come inside my IoT hub right here and click on the shared access policies, you can see some of the several access policies that are already defined when you create your IoT hub. One is the IoT hub owner that has permissions such as registry read, registry write, service connect, and device connect. And so if I was to use a connection string, like, because with this kind of a policy, I can be able to access its particular connection string that I can use to access this IoT hub, or rather I can use to have a device connect to this IoT hub using a particular connection string using this policy. Jaylene, what will be the security risk by using the IoT hub owner to access this IoT hub from any device?
Clearly, you can tell that the IoT hub owner has too much permission. So you can imagine if someone compromises that account or that policy, it's like they have access to everything. So we have this policy of a least privilege. So if you have a service connect, you make sure that it has only the permitted permissions for it to do its duty. So by that I mean just give it the rights that it needs. Just give it the permission that it needs to perform its job. Don't give it too much like the one that the IoT hub owner has. Because I see the IoT hub owner has registry read write, service connect, device connect, all of them. So you can imagine in a scenario where that is actually compromised and the IoT hub owner has connection to almost like how many devices? Like if I have a deployment of like 100 devices, then I'll be able to compromise all of them.
Yeah.
Yeah.
Thank you, Jolene. So the most important thing to do is to create a new shared access policy, give it a name. So you can just click on shared access policy, give it a name, and maybe this is one for that you just want to read. So you can just check on read, and then you give the policy a name, and that should work. So like if you just want to read, or you just want to connect the device and hopefully write to the IoT hub, you just give those two permissions, and then you click add, and that way you'll have limited access, or rather specified limited access using that shared policy.
Okay. The other recommendation that we had was defining access control for backend services. So maybe Josh, you can also show us how to do that on Azure.
All right, so I'm going to bring back this, and so let's like create a shared access policy here that can do a read, that can do maybe a read and a write, and no device connecting, because the example that Jailin has mentioned, it's for connecting to backend services. So in many cases we are just reading from the IoT hub. So maybe I can just say like maybe backend policies. um
So some of
Rather,
these
let me just call
services,
it.
maybe Cosmos DB,
Yeah,
app service, logic apps.
I'm just going to create this policy. And so this one has only registry read and registry write. And so as this is creating, if you come down here and scroll, or rather scroll up to built-in endpoints, sorry, you might have to wait until this finishes creating. All right, it's still creating. So if you come here, right here, inside here on built-in endpoints, the native way to share, or rather to share messages, or rather share data or information within Azure, maybe from between different services, like from IoT Hub to maybe a backend service like Cosmos DB, or you want to save the data to a storage device, or you want to access that data and further and process it in other ways through something like maybe an Azure function or Azure Logic Apps. One of the ways is by the use of event hubs, and you can just come inside here, inside the built-in endpoints, and inside here you can see we have the event hub compatible name. So this is the name of your event hub, and then inside here you can specify again the shared access policy that you're going to use for this particular endpoint. And so like I can be able to change, you can be able to change it here. So like maybe I can try refreshing here. Just a little bit, some few more seconds.
Okay, maybe when that is loading, Josh. So I might be wondering. So, yes, I have an IoT device. So what would be the ideal, or what's the normal layers of or architecture of IoT? Because I have my IoT device. I know that it has a firmware, it has a sensor, it's transmitting data in some way. So, okay, from past experience that I know that there are three major layers for any IoT model, isn't it?
Yeah, so the basic architecture is you have your IoT device. Sorry, you have your IoT device, and this device can directly connect to the IoT hub. So can directly connect to the IoT hub, or optionally, you might have several IoT devices that connect to a cloud, to a local gateway, and then the local gateway connects to IoT hub. So the IoT hub acts as the cloud gateway, and then from IoT hub, you can make any information that is coming in from the device accessible to other services, such as the backend services we were talking about, which are the event hubs. Sorry, other services, backend services like Cosmos DB, Azure SQL, Logic Apps, Azure Functions, and you do that by use of the event hubs. So as I was saying, you just come inside here, and I see a small mistake we made when we were creating our access policy is that we did not give it access. We did not give it the service connect, so the service connect permission. So if you come here, we created these. So for it to work on, for it to work with the backend services, or rather on the event hub, we need to give it the service connect permission. You might not necessarily need the right permission, and then we can save that. And then once you go back now to the event hub, that makes the data that is coming in accessible to other services on Azure. You can be able to select this particular you can be able to select this particular access policy and get the connection string associated with that. That way, any service that is connecting to IoT hub only has the permission of service connecting. It cannot do read, it cannot do a write, and it cannot do a device connect, because you've only granted this particular permission.
Yeah. So maybe going forward, we'll use this example of, so we have these IoT connected traffic lights. Like where we are, we have all those that have sensors. So whenever someone is passes and it notes that this person has defied a particular traffic rule, and it sends out notifications. So in such a case where we have thousands of IoT traffic lights, so the devices themselves will be the IoT device, and it has a sensor, and then now it will be transmitting probably to a particular gateway, and then now that gateway is transmitting or connecting to the IoT hub, and then now from there you're connecting to the backend services. That's what you're saying, isn't it? Yeah. Okay. So there's the okay for the three IoT, for the three layers. They're commonly known as, the first one is the perception and execution layer, so which is mainly the smart devices themselves. And the second one is the network layer, which provides the communication infrastructure now for transmitting. And the third layer is the cloud or application layer, which integrates, manages, and analyzes data from the IoT devices. So it's good to know the three major layers or architectures for IoT solutions. Okay, going on further to data protection. So for data protection, we're looking at secure device authentication. I think you're only as secure as your authentication, your identity and authentication as well. So in this case, you'll find that in most cases you're using secure tokens, or you'll find that some devices actually using certificates as well. So you have to make sure that you're using security tokens based on chosen protocols that are actually secure, sort of like HTTPS as well. Another recommendation for data protection is secure device communication. So IoT Hub makes sure that you are using TLS standards, so supporting version 1.2 and 1.0, but we actually recommend using TLS 1.2 and higher for maximum security. In most cases nowadays, you're phasing out the use of TLS 1.0 because it's becoming insecure. So whenever you're purchasing or incorporating like an IoT device, just make sure that it's compatible with the latest or strong encryption standards. We also have secure service communication. So IoT Hub provides the endpoints to connect to the backend services, as we mentioned earlier. So we have to make sure that no endpoint is exposed or there's no unencrypted channel. So even if you're doing your communication, you have to make sure that everything is end-to-end secure. So maybe Josh, you can show us how to do secure service communication.
Right. So I'm going to bring in again this, and we can begin right here with the secure device authentication. So every time you're creating a new device on IoT Hub, you can do this directly from the Azure portal, or you can use the device provisioning service. And if I was to create a new device inside here and and provide uh, provide the ID, maybe I can call this LAN live SIM. You can be able to provide the particular authentication type that you actually need for your device. As Jolene has mentioned, you can use the symmetric key, the X509 self-signed certificate. So you can use these certificates. You can use the symmetric key, and that is very, very, very much important, so that you can ensure you have your device authenticates correctly to Azure IoT Hub. So in the moment you do that, the moment I create that device with the particular chosen once I create this device with the chosen with the chosen identity, then I have to authenticate against IoT Hub with that particular. If I selected the use of the X509 certificate, then I need to provide that every time I need to provide that when authenticating against IoT Hub, and the same case if I selected the use of the symmetric keys. Then the other thing was the secure device, the secure service communication, and that's just the same as mentioned by Joeline. That is, you can find that within IoT Hub, you are able to get this endpoint, which I mentioned. It's the Event Hub, this Event Hub compatible endpoint that allows backend services such as Azure Storage Event Hubs to connect using the TLS protocol, and no endpoint is exposed on an encrypted channel. Sorry about that. And so up to this point, like, you're sure your data is passing between these services in an encrypted way. And so the most important thing is to ensure that once this data reaches the backend services for storage or analysis, you are able to employ appropriate security and encryption methods for that particular service to protect sensitive information. So, Jolene.
Awesome. So far we've looked at general recommendations for securing your IoT solutions. We've looked at identity and access management. We've looked at data protection, and now we're going to look at networking. So in networking, the two recommendations are to protect access to your devices. Keep hardware ports in your devices to a bare minimum. I've seen a scenario where you've hardened, you have encrypted communication, but once you have this particular port available, that if I just plug in, I have access to your firmware, I have access to your backend completely. And in such a case, you've not controlled access to that device. So as in, it's as good as compromised. So we have to make sure that you build in mechanisms to prevent physical tampering of the device. Another recommendation during networking is to build secure hardware. So you have to make sure that you incorporate encrypted storage or trusted platform module to keep devices and infrastructure more secure. I'll give an example of one attack that happened in 2016 for the Mirai botnet. So the Mirai botnet, Mirai is a malware that infected smart devices that run on ARC or ARC processors. So turning them into a network of remotely controlled bots, or rather called zombies. So this network of bots, which is also called a botnet, was used to launch distributed denial of service attacks. So because they had not physically secured the IoT devices, they were compromised and used to attack other IoT devices. So remember this scenario where we are talking about IoT traffic lights. So if I'm able to attack them, to attack even one, and then I can be able to compromise that and compromise all the connected IoT devices. But if there's anything else that's connected, I'm able to compromise all of them. You can see the extent of damage. So the Mirai botnet was quite something. And going on further, the last bit of recommendation for securing IoT solution is monitoring. Monitoring. That's quite important. There's this meme where there's a fire and then someone is carrying a person on their arms, and then so the person who is being carried out of the fire is actually logs and monitoring, just for you to do a little bit of investigations after post the fire. So that's how much monitoring is important. So during monitoring, you have to make sure that you're monitoring unauthorized access to your devices. You also have to make sure that you're monitoring the IoT solution from the cloud itself. And you're doing this using Azure Monitor. And you can also use Azure Sentinel as well. Josh will cover that a little bit further. And you also have to make sure that you set up diagnostics. So maybe Josh, you can just share your screen and then we show how to actually enable monitoring from IoT-hub. So by default, monitoring is enabled. So it's just up to you to go in and customize your alerts. So you can go in, we have under monitoring, you have alerts, you have metrics, you have diagnostic settings, logs, and workbooks. So just go in and create your alert rules under metrics. So under this, you can create a rule. So if you know that you have like 100 IoT devices and they should be up throughout or something, and then in a scenario where you find that you now have like 1 or 5 devices, then that's an alert by itself, because it means that there's some other entity that's connected to your network. Maybe you can go back, Josh.
Loaded finally.
Yes. So apart from creating alerts, you can also so you can also check your metrics. You can do logs. You can do also diagnostic settings. So just go in and play around with these monitoring settings, as well as, so you can add a diagnostics setting. So if it's for all logs, and then you can create a category for maybe connections or devices. Now just go in and see how it will work to your advantage, because you can, yes, as Josh has just selected, you can stream to an event hub and his subscription is there, the namespace. So it depends with what you have enforced. So apart from diagnostic setting, you can also use the other features of Azure Monitor in logs. So here you would use Custo query language just to further query your logs. Maybe you'll find an anomaly that maybe someone was trying to compromise. You'll be able to do that under logs. So you can also further go in and create workbooks for your particular monitoring use case. But in most cases, you'll go ahead and just whatever you need in terms of monitoring, you have it here in terms of creating alerts, metrics, diagnostics, settings, logs using KQL, and workbooks. So we can go in. further. So so we need to know how to protect these IoT solutions. And to protect the IoT solutions, you need to secure your device provisioning and authentication. We mentioned this earlier during the recommendations. You also need to secure connectivity. Make sure that Azure IoT Hub supports secure connectivity with proven protocols. And you also need to secure processing and storage in the cloud. So Microsoft Azure offers a complete cloud solution. So one that combines a constantly growing collection of integrated cloud services, analytics, machine learning, storage, security, networking, and industry-led commitment to the protection and privacy of your data. That's why the Azure IoT Hub offers a fully managed service that enables reliable and secure bidirectional communication between IoT devices and Azure services, such as Azure Machine Learning, Azure Stream Analytics, Cosmos DB, etc. So you need to make sure that, yes, you're securing your device provisioning, that you have secure connectivity throughout, and you're also making sure that you have secure processing and storage in the cloud. We'll go next. Securing an IoT infrastructure requires a rigorous security in-depth strategy. Remember, you're only as strong as your strategy. Because if you don't have no strategy, if you have no strategy, then it means that you're just open to just being broken, or your system just being compromised. So the strategy requires you to secure data in the cloud, to protect data integrity while in transit over the public internet, and securely provision devices. Remember the three pillars of security, the CIA triad, where we want to cover confidentiality, integrity, and availability throughout. So each layer provides greater security assurance in the overall infrastructure. So this security in-depth strategy can be developed and executed with active participation from various players, including like who actually develop the IoT solutions or are involved in the maintenance of the IoT devices. So Josh, if I'm talking about now the IoT traffic lights, who are these players that are involved from the word go in terms of these IoT solutions?
We have the hardware manufacturer or the integrators. So these are the individuals who are responsible for manufacturing the IoT hardware that is being deployed, the integrators assembling the hardware from various manufacturers. They can even be suppliers who are providing IoT hardware for IoT deployed, manufactured, or integrated by other suppliers. So that's the first player, people who are actually dealing with the hardware with the hardware that we're using for IoT solutions. The other players involved in these are the solution developers. And so the development of an IoT solution will typically be done by the solution developer. So this may be someone in-house within the organization who is building these IoT solution. And this person can develop the various components of the IoT solution from scratch. They can use other open source components, or they can use SDKs. They are the people who are actively building the solution. And then we have the deployer. This can be the same person who was building, or rather the same person who was developing. Alternatively, it can be a completely different player who after the solution has been developed and it needs to be deployed. This is the person who now does the deployment of the hardware, the interconnection of the devices, and the deployment of the solutions on hardware devices or on the cloud. And the final part we have are the operators. And so once it's deployed, any IoT solution will require long-term operation of monitoring, upgrading, maintenance, and this is done by this can be done by an in-house team that comprises of different specialists. But these are the people who generally they maintain and monitor and probably even upgrade the different IoT solutions. And all of these different players who are involved, you need to have a strategy to ensure that security is taken care of in all these different phases during the development and deployment of the IoT solution.
Mm. For sure, security is everyone's responsibility. So if you're a manufacturer, you have to make sure that you scope hardware to a minimum requirement. And you also have to make sure that your hardware is tamper-proof. You have to make sure that you build around secure hardware. You have to make sure that upgrades are secure. And you also have to make sure that if there's a 0 day and your hardware is actually vulnerable, you push updates to your clients as soon as possible and inform them that that particular device is vulnerable. So for IoT solutions developer, they have to follow secure software development methodology. Development of secure software requires ground up thinking about security. You have to think of security from the onset. Security is not an afterthought. It becomes more expensive when you instill or you configure security later on in the software development lifecycle. And you have to choose open source software with care. So we have this component called software composition analysis in DevSecOps, whereby we're talking about third-party components, open source software that you're actually incorporating, which bring vulnerabilities into your whole solution if you do not make sure that you're using secure third-party integrations. You also have to make sure that you're integrating with care. You're just not integrating with any libraries and APIs. You have to make sure that you do thorough security checks on your integrations. So for the IoT solution deployer, you have to make sure that you deploy hardware securely. So IoT deployments may require hardware to be deployed in unsecure locations, so such as public spaces or unsupervised locales. So in such situations, you ensure that your hardware deployment is tamper-proof to the maximum extent. You also have to make sure that you keep authentication keys secure. So that's for the IoT solution deployer. And finally, for the IoT solution operator, you have to make sure that you keep the systems up to date. Remember, as I said earlier, 0 days, you have 0 days every day. You have to make sure that you push updates as much as possible to fix and or patch particular vulnerabilities. You have to protect against malicious activity. You have to make sure that you audit frequently. Make sure that this is part of your monitoring in terms of your metrics. You have to make sure that you audit frequently. And you also have to make sure that you physically protect the IoT infrastructure. That's why we're talking about malicious use of USB ports and other physical access. Make sure that your hardware is actually tamper-proof. We also have to make sure that you protect cloud credentials, because if you put your credentials in an insecure way, then it's as good as compromise, as in everything is, I can be able to access your IoT devices, I can be able to root or just do malicious stuff with that. So next, we'll just cover threat modeling and mitigation techniques in brief. So Josh, how do you think an attacker would attack an IoT solution? So I have this, yes, as we were talking about traffic lights, the whole IoT solution, which is connected to a gateway, which is connected to an IoT hub and to the backend services. Where would I, as an attacker, try and target?
Mhm. All right. So I believe, as mentioned from the previous slide, with everyone's stakeholder, with every of the key players that we've mentioned in the previous slide, I believe some of the areas you could, and some of the areas that an attacker might begin with are, in situations where the hardware deployment isn't tamper-proof, like if USB or other ports are available on the hardware, and attackers can use these as entry points, right, Jolene?
Yes, I think that's why even sometimes you go to a facility and then you find the hardware is up there where it's almost impossible to reach. I think that's some level of control. Though if someone is very intentional, they can be able to reach there, and just if you haven't done hardware tamper-proof and do some bit of compromising there.
Yeah, and I also think, I also believe another thing that is very key is uh, uh,
we always encourage developers who are building our IoT solutions to use the device SDKs that we provide, and they are open source and available in very many different languages. Whether you're using Python, C Sharp, C, you can be able to use these different device SDKs. What could be the challenge, or what could be the threat in the event the developer just used open source, any other open source library, and not the recommended device SDKs?
Mm. Then that's an insecure integration by itself. That means that you can easily be compromised through your integrations. So I'm thinking now for IoT, I might be using APIs, I might be using some form of communication, which maybe might not be secure. That can be an avenue that can be attacked by a hacker. If your firmware is insecure, that's an avenue that can be used by an attacker. So these are all things that we look at during threat modeling. So we do threat modeling early on during the development or during the integration or the IoT solution itself. So the objective of doing threat modeling is to understand how an attacker might be able to compromise the system, and then make sure appropriate mitigations are in place. So you're trying to emulate, okay, so what vectors can be used by an attacker? So if I'm using, if it's for the network, can that attacker try and do man in the middle? If it's the gateway, is it secure? Is it securely integrated? So these are all the things that we look at during threat modeling. So the threat modeling process is composed of 4 steps. So you model the application, you mitigate threats, you enumerate the threats, and you validate the mitigations. So, so who performs threat modeling? So threat modeling is a process like any other. So it's good idea to treat the threat modeling document like any other component of the solution and validate it as a team. So many development teams do an excellent job capturing the functional requirements for the system that benefit customers. However, identifying non-obvious ways that someone might misuse the system is more challenging. So that's where threat modeling can help development teams understand what an attacker might do and why. So during the transition, we look at something called stride. You need to take note of this stride. So stride stands for S for spoofing, T for tampering, R for repudiation, I for information disclosure, D for denial of service, and E for elevation of privilege. So that's one thing that you need to take note of is stride. So for an IoT solution, threats most commonly target the physical devices or one of the trust boundaries identified in this simplified threat model that you have. So considering the strike definition, so spoofing is an attack where an attacker pretends to be someone they're not. And then looking at tampering attacks occur when the attacker modifies the data in transit. Repudiation occurs when someone performs an action and then claims that they did not actually do it. So this is where it's quite important to do monitoring as well. So at least you can have proof that someone actually did something at that particular time. I for information disclosure. Information disclosure threats are straightforward. An attacker can view data that they're not supposed to view. D for denial of service occurs when an attacker can degrade or deny service to users. And E for elevation of privilege, where an attacker, this threat occurs when an attacker has the ability to gain privileges that they're not normally having. So going on further to the last bit of this module, so we look at common threats against physical devices. So keeping in mind stride, in devices, we're looking at assigning identity to the device and authenticating the device. So a risk here is replacing the device or part of the device with some other device. So that one will be some form of spoofing. That's the threat for spoofing. So under device, again, we also have tampering, information disclosure, and denial of service, whereby the risk is if someone is tampering the device physical interface, how are you sure that the device has not been tampered with? Yes, so we have all these in place, mitigation in place that you can use to secure your device. So another one for device, whereby we're trying, the threat is elevation of privilege, is whereby if the device allows for individual action to be performed based on commands from an outside source. So if I'm able to compromise a particular device and then I'm able to elevate my privilege to a point where I'm even compromising IoT-hub, you can imagine the extent of damage. So we have all these examples of threats, which I leave to you to read or go through. We have some for IoT edge gateway. We have some for next for device to IoT hub. We also have some threats which are targeting tampering, information disclosure, and denial of service. We also have some threats for IoT edge gateway to cloud gateway. So take some time to just go through these scenarios of threats and see how you can be able to identify the risk and do some mitigation and implementation of those particular mitigations. So going on over to the knowledge check. So let's go ahead and test our knowledge in the chat. So we have a question here. So when working to develop a secure IoT solution, which of the following tasks is typically assigned to the IoT developer role? Remember we covered people tasks. So the first one is make hardware tamper-proof. The second one is protect against malicious activity. And the third is follow secure software development methodology. So please engage with us on aka.ms/polls and share with us your answers to this. So we are asking you, when working to develop a secure IoT solution, which of the following tasks is typically assigned to the IoT developer role? Head on over to aka.ms/polls. We'd like to know your answers. Josh, what do you think the answer is here? We can just eliminate some.
So definitely it's following secure software development methodology, because as the developer, it's their responsibility to build the firmware. And so it's very important for them to follow secure software development methodology. Making the hardware tamper-proof, that's the responsibility for the manufacturers. And then protecting against malicious activity. Where will that fall under, Joelyn?
Protecting against malicious activities, the operator, the normal day-to-day. Yes. I think we'll skip on over to the next module.
Right. So we've covered about the examining the we've covered the first module, which was on examining the security fundamentals of IoT, and that gives you a brief understanding of the IoT security fundamentals. Now, moving forward, I want us to look at Azure Defender for IoT, and here we'll review the Azure Security Center, also Azure Defender for IoT options and feature of the agent-based implementation. And finally, we'll examine the hub security alerts, and custom implementations. So one of the things to note is that Azure Defender for IoT integrates with the IoT Hub to provide a built-in support for the IoT Hub service and enhance support for the devices. So that means by default, Azure Defender for IoT is integrated in IoT Hub, and that's why you saw in the demos we were doing, we could just from within the left blade within Azure IoT Hub, I could be able to open Azure Defender for IoT. And so by the end of hopefully by the end of this module, you should be able to describe the features of an Azure Defender for IoT agent-based implementation. And in just a few minutes, try to explain what agent-based implementation actually is. So to begin with, Azure Security Center provides you with the tools that you need to harden your network and also to secure your services and make sure you are on top of your security posture. Therefore, it helps to address the most urgent security challenges, and these most urgent security challenges are as follows. The first one is rapidly changing workloads. So it's both a strength and a challenge of the cloud, where on one end you have users who are empowered to do more, and on the other end, how do you ensure that the ever-changing services people are using and the same services that people are creating on top of are up to the security standards, and they also follow the security best practices. Therefore, Azure Security Center will help you address this particular challenge. The next challenge that Azure Security Center helps to address is the increasingly sophisticated attacks. And Jolene, maybe can you help us understand how Azure Security Center helps mitigate or helps address this particular challenge?
Yes, for Azure, Microsoft Defender for Cloud or Azure Security Center, it gives you a secure score for all your assets, and it gives you recommendations of how to actually patch them. And as of late as well, you can be able to detect 0 days. It will give you notification that there is actually this zero day that is actually targeting or has compromised that particular resource. So you can be able to fix it as early on as possible.
Thank you. And the last challenge that Azure Security Center addresses is that of shortage of security skills. Jolene, how is this? Like you're in the security field. How does Azure Security Center address the challenge of the challenge that security skills are in short supply?
Definitely, we have very few security professionals compared to the number of attacks or like compromises that are actually being done. So it actually helps in such a way that it makes it easy for you to actually patch. You don't have to have the security knowledge or the extent of investment in security resources. Because it gives you recommendations, it tells you that you're actually vulnerable in this particular resource, this particular CVE, and this particular CPE as well, if it's a particular platform. And it tells you that you need to patch them and gives you a secure score and tells you that this is like you're not doing good at all. You're maybe at a 4. So yeah, it gives you that overall security overview and it gives you recommendations.
Thank you. Now that we understand the major challenges that are addressed by Azure Security Center, how does it allow you, or rather, what tools does it provide you with to ensure you're protected against these challenges? The first one is it provides you with tools that allow you to strengthen your security posture. Therefore, Azure Security Center will assess your environment and enable it will assess your environment and enable you to understand the status of your resources and whether they are secure. So just directly looking at it, you'll be able to know whether your resources are secure and also see the status of your resources. The other thing is that it's also going to provide you with tools that protect you against threats. So it's going to assess all your workloads and also raise threat prevention recommendations and threat detection alerts. And the final thing is that, and this is very interesting, is that, or it's very important, is that it allows you to get secure faster. So because everything is down, as everything in Azure Security Center is done in cloud speed, and also is natively integrated, deployment of the security center is very easy, and it provides you with auto provisioning and protection with Azure services. So you're able to get secure faster. One is because everything is done in cloud speed, and also that it's natively integrated into Azure. Now, the next thing that now moving forward, that we understand what Azure Security Center is to examine Azure Defender for IoT and Azure Defender for IoT, its features and also the requirements. But before we move on, Joelene, uh, what is Azure Security Center? What is it currently referred to as of right now, and also Azure Defender for IoT, just to avoid confusion for anyone who might go through the documentation?
Yes, for Azure Security Center, it's Microsoft Defender for Cloud, and for Azure Defender for IoT, it's still being used interchangeably, but it's still Microsoft. It's now Microsoft Defender for IoT.
Thank you. Therefore, Microsoft Defender for IoT, and as for these round modules, we'll constantly hear us referring as Azure Defender for IoT. Now, this one is a component within Security Center. So I've mentioned about what the challenges the Security Center is helping to address, and also, the tools, what it equips you with, the tools that it equips you with, what they are able to do. Now, Azure Defender for IoT, or Microsoft Defender for IoT now itself, is a component within Security Center, and it's integrated within Security Center, and it brings advanced intelligent protection of your Azure and hybrid resources, and also your cloud workloads. So we're going to look at Defender for IoT, which is now a component within Security Center. Now, Defender for IoT, it offers a set of two capabilities to fit your environment needs. One of the capabilities is for end user organizations, and the other one is for device builders. Now, for end users organizations with IoT or OT environments, OT meaning operation technology, Azure Defender for IoT will deliver an agentless network layer monitoring that can be rapidly deployed, and that will easily integrate with diverse industrial equipment. Then the other capability that Azure Defender for IoT offers is for device builders and IoT solutions. For device builders and IoT solutions that are built around IoT-hub. Therefore, Azure Defender for IoT will offer a lightweight micro agent that supports standard IoT operating systems. And sorry about that. So for device builders and IoT solutions that are built around using IoT, using Azure IoT-hub, Defender for IoT will offer a lightweight micro agent that will support IoT operating systems such as Linux, RTOS, that is the real-time operating systems. And this lightweight agent will ensure that security is built into your IoT or your OT initiatives from the edge to the cloud. And I'll show you the a sample architecture for this. And this is what we've been showing you in the previous demo. Now, the agent-based option for Azure Defender for IoT will include, and now this is for device builders and IoT solution, it will include an IoT hub integration, and it's also going to include the device agents, which are optional. It should also include the Send Security Message SDK, and also an analytics pipeline. Now, moving forward, this is the Azure Defender for IoT agent-based solutions. This is for you as a builder of IoT solutions. Therefore, the Azure Defender for IoT agent-based solution, it is implemented using the following architecture. So you have on your device, on your IoT device, that could be running maybe a Linux operating system, an Azure Real-Time OS, or any other OS like Debian or Ubuntu. You have the Azure Defender for micro agent. Then remember when Jolene asked me about the basic architecture of any IoT solution, I mentioned that you have your device, and then this device can connect to an optional local gateway, and then the local gateway connects to the cloud gateway, which in this case is the IoT hub. Or alternatively, the device can connect directly to the cloud gateway. That is, it can connect directly to IoT hub. Therefore, when you have this architecture on your IoT device, you have the Azure Defender for IoT micro agent. So you have your you have Azure IoT Defender for micro agent, and I believe this is still in preview. I believe so. And then if you're having your edge devices, you have your Azure Defender for IoT micro agent as well, because these again, it's learning on on your edge device. So like you have these several devices that maybe are connecting up to this local gateway, which is an edge device. That is, it has some capabilities that have been offloaded, and it performs these workloads on the edge of the cloud. Therefore, again, there you have your Azure Defender for IoT micro agent. And then once you get to IoT Hub, which is the management cloud gateway. So this is the cloud gateway. You have you have the Defender for IoT that is built in into IoT Hub. Then from there, the Azure Defender for IoT can be able to give recommendations, assess vulnerabilities and threats. You can be able also to create alerts, custom alerts, depending on the information that is coming in from your devices. So that is it for the architecture of the agent-based solution.
Josh, maybe I can ask, how do I go about installing this micro agent?
Thank you. That's a good question. So on the IoT Hub, the Defender for IoT is already built in, and I can pull that in just to emphasize on that point. You can see right inside here, inside IoT Hub, you have inside IoT Hub, you have Defender for IoT. So like on IoT Hub, you really don't have to do anything. But when you're creating your IoT devices, either your edge device or any other device that and it's running in either of these operating systems, what you have to do is to install the Defender for IoT micro agent, and there is a resource on docs, and there is a resource on docs that allows you to install the Defender for IoT micro agent, and also to authenticate those. You have to install, and then you authenticate the micro agent. And so again, for authentication, you can authenticate using the certificates as well. So you just have to install it onto your device, and you're good to go.
Awesome.
All right. Moving forward, we'll just do a quick demo for Azure Defender for IoT. So we've covered most of this in the previous. We've covered most of these in the previous LAN module when Joelene was talking about the IoT security fundamentals. Now, inside here, once you create your IoT hub, one of the most important thing to note is that Defender for IoT, it's not region specific, so you don't need to deploy your IoT solution to a specific region so that you can use it. So it's non-regional. It's not dependent to a specific Azure region. So you can create it for this one. It's created it in the West Europe region, but you can create it in whatever region, and you can create your IoT hub in whatever region, and it's just going to work. Another thing is to note is that, as I said, Defender for IoT is enabled by default for every IoT hub that is created. So the moment you create any IoT hub, Defender for IoT is automatically enabled, and it allows you also to gather IoT insights and also to see reports that can be viewed directly within the IoT hub UI. So like just within your particular IoT hub, you can be able to come inside here and you can be able to come inside here and see your reports and any other IoT insights. The last important thing, Jolene had asked a very important question, like how do you install, how do you get the Defender for IoT for the micro agents? And I mentioned you have to download, you have to install that on your particular device. And the one thing I need to mention is that the list of the supported devices and platforms is continuously growing. So you have it supports Linux versions for C-based agents, and also both Linux and Windows versions for C# based agents. So you in the event you're building your IoT solution, you're well covered on that. Now, just to highlight, if you come inside here, in this IoT hub, I have some devices connected. So typically, you can have several devices that are connected to your IoT hub, and you can have them sending messages. So I have some 3 simulation devices, and I have one physical device that I have one physical device that I actually have right here connected to this IoT hub. And if you come inside Defender for IoT under overview, you can be able to see threads. You can be able to see recommendations for different devices. You can be able to see whether there are any alerts. If you've already created security alerts, you can be able to see the status of your devices. So like you see for these ones, there is no severity for any of the devices. But if you had any device, like for example, you had a device and maybe you had a port that is open, those are things you might be able to see directly from, and that is okay, a port that is open that poses a security threat. Those are things you might be able to see directly from within Defender for IoT in the overview section. If you come within the security alerts inside here, you can be able to create custom alerts. So you can see right here, there are no alerts, but if you've created your own custom alerts, you can be able to create your alerts. And so what you just do, you can just come inside here and you create your rules for alerts. Like for example, maybe you just want to see, maybe you have an alert for messages deliveries that were completed, or how many messages were rejected and all of that. You can be able to have that, and you can be able to view those alerts. So that's the most important. Oh, one more thing I forgot to mention was under recommendations. Currently there are no recommendations, but again, once Defender for IoT, you've installed the micro Defender for the micro agent on your devices, maybe on your edge device as well, you're able to see your recommendations as well for all the devices that are connected to your particular IoT hub. So that's it about the Azure Defender for IoT, and we're going to jump in into the knowledge check. So a developer has started an investigation of Azure Security Tool. What is Azure Security Center intended to help with? Is it intended to help securing the device and securing device communication as they transmit over the wire? Is it securing the network and the services, or is it developing threat models? Yeah, so
we can share our answers at aka.ms/polls. So what do you think the answer is? Let us know.
okay.
You see, some people are getting the answer. So, Josh, is it securing the devices and securing device communications as they transmit over the wire? No.
No.
Yes, so definitely it should be securing the network and the services, because Azure Security Service provides you the tools needed to harden your network and secure your services and to make sure you're on top of your security posture.
Jolene, you had mentioned about threat models. Who develops the threat models?
So as earlier mentioned, it should be the team, because remember there is a point whereby a hacker can be able to compromise your whole solution. So it should be a team effort whereby we are all coming in and just trying to brainstorm. So what vectors can be used to compromise, which integration is actually vulnerable, or which one is exposed, which one is, to some extent, just some form of brainstorming. We have a tool called Microsoft threat modeling tool, which you can use to do your threat modeling. We also have another one called Threat Modeler, which is quite good. Yes, for threat modeling, to drop or scale your threat modeling.
All right. The next one is, which of the following choices is a feature of Azure Defender for IoT? So Azure Defender for IoT is enabled by default when an IoT hub resource is created. Azure Defender for IoT requires device agents. Azure Defender for IoT requires a DPS enrollment pipeline. DPS here means device provisioning service.
So remember to share with us at aka.ms/polls. So which of the following choices is a feature of Microsoft Defender for IoT? So Josh, you've just taken us through it, and I believe the answer should be, drum rolls, should be A, isn't it?
Yes.
Yeah.
So by default, when you create an IoT hub resource, Azure Defender for IoT is enabled for you. There is no extra step for you to configure to have Defender for IoT integrated into your IoT solution. It's by default created for you. So it does not necessarily require device agents, because like you once you create an IoT hub, you already have Defender for IoT. If you want to secure your devices using Defender for IoT, which is what we recommend you do, you now install Defender for IoT on your device agents. But it doesn't mean that without device agents, it doesn't mean that it's completely, or it's dependent onto the device agents. So we've come to the end of this Learn module. the second one, where we have understood security center and also defender for IoT, and also the and also the alerts on azure-iot-hub security. So at this point, I'm going to open for questions. If anyone has a question regarding these two LAN modules on examining security fundamentals for IoT and examining security center and defender for IoT.
Josh, that reminds me of a particular joke or meme that was going around. There was this employee, or in our case, the operator, that went to his boss and said that all our devices are now 100% secure. And then the boss was like, "How did you manage to do that?" And then he was like, "I turned them all off." But from today's session, I think you can just say that they're all secure because you've integrated Microsoft Defender for IoT as well as Microsoft Defender for Cloud, which is as well as Azure Security Center, because you have a holistic view of your security vulnerabilities and recommendations. So it's up to you to patch them and fix those recommendations.
Right. And a quick question to you, Jolene. Is it compulsory for an individual who is building their IoT solutions to be a security expert for them to integrate to Azure Security Center or to Defender for IoT?
No, 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 no. You actually just need the bare minimum in terms of understanding the security requirements, enforcing identity and access management. For communication, just need to know the correct encryption algorithms that you need to enforce. If it's for data on transit and data at rest as well, you just need to know which ones are strong enough, which ones are recommended, which should be available as well from Microsoft Defender for Cloud, which will tell you that you're using an insecure algorithm here, you're not encrypting your data on transit here. So as long as you've enforced and gone through the recommendations, I don't think you need that level of security understanding, but it's a good to have.
Thank you. Right. We'll just wait for a minute or two if anyone else has a question, and we'll try to answer or respond. So if you have any question, just send them in and we'll try and answer them. Okay, I can see so a question that asks, are there any workbooks built in? So let me just bring in my screen again. So if you bring in the if you open the IoT Hub and you scroll down to monitoring and workbooks, currently you can only start with your own new or empty workbook, but you can click on this link to view some already built workbooks. These are for IoT-edge, and you also have these ones for the log insights. So these are the only ones that are available, and you can be able to open, edit, and make changes to them. Another question was, does this cover OT environments as well? Yes. So Defender for IoT will cover both IoT and OT for operation technology environments as well.
So maybe Josh, I don't know, someone might be wondering, so what's the difference between IoT and OT?
So
Yes. So what's the difference between IoT and OT?
okay. So generally speaking, OT devices. Yeah. Okay. So OT devices will control the physical world. So while the IT systems, on the other hand, will manage data.
So I think OT is kind of outdated as well. It was what was used in the previously. I think we are moving more and more towards IoT, but not to say that some people are not still using OT. So that's why the services are still available for IoT, OT solutions.
Yes, and actually IoT technologies tend to be more of a complement of OT systems.
Yeah. Okay. So we need to complete our interactive learning exercises using the links aka.ms/learnlive 2022-06-06 A1 and A2. So, and you can also scan the QR code and go on over and complete your learning exercises for the two learn modules. Thank you very much for attending the session and learning with us. Hopefully we'll see you in another IoT security session very soon.
So, and next, do not miss the next Microsoft Learn Live session, which is implementing Azure functions, happening on June 13, 1 p.m. to 2:30 p.m. Pacific. Thank you for joining us today.